Bristol Community College, Mathematics with Dan Avedikian, Math 011, Arithmetic, Section 4.9, Problem 14. This is Section 4.9, Problem 14. It says, on the day a baby is born, its parents invest $500 in a mutual fund account at 12% interest compounded quarterly. How much will be in the baby's account by the time it is 65 years old? Now, of course, it's not going to be a baby at that point, but I picked 65 because it's a typical retirement age. So, first of all, which of the two formulas are we going to use? Our choice is a simple interest formula, compound interest formula. Because the question mentions compounding specifically, we want to use the compound interest formula instead of simple interest. And the compound interest formula is A equals P times, in parentheses, 1 plus R over N to the exponent N times T. So let's go ahead and fill that in. A, the final amount, which is what I want to find, equals P. P is for principal or initial investment. For this problem, that value of P is 500. Times, we open the parentheses, 1 plus, now we have fraction in the numerator R. R is the rate as a decimal. So if we look through the problem, the rate is 12%. To write it as a decimal, it's just simply 0.12, right? It's going to be as a decimal. N is the number of times compounded per year. So if we look through the type of compounding we find is quarterly. So the number of times the bank puts your savings, your interest earned into your account is 4 times a year for quarterly compounding. So the value of N in the denominator here for quarterly compounding is 4. Close the parentheses. You have an exponent of N times T. Again, N, number of times compounded per year. For quarterly, that would be 4. And T is a time in years. It's going to be 65 because we're going from birth to age 65. That's 65 years. So that's how it fills in. So start the math. Again, there's a lot of options that you can do. What comes first? There's one correct answer. It has to be the work in parentheses. You have a multiply here, 500 times the parentheses. In the parentheses, you have an add and a divide. You have an exponent with more multiplication. If you have parentheses, they really need to be done first. But even within the parentheses, we have an add and a divide. You have to pick the right one to do first, and it has to be the divide. So let's start with that. Oops, that'd be my calculator. So 500 times in the parentheses, 1 plus 0.12 divided by 4. I can actually do that. That's 0.03. Because 12 over 4 is 3, but because the decimal is 0.03. The exponent, I can even do that as 260. Just double the 65, you get 130, double again, 260. And now I can finish my work in parentheses. 500 times, open the parentheses. 1 plus 0.03 is just 1.03. That's not too bad. Now that's as far as I can go without a calculator. Oops. So now that I have my calculator, I'm going to have to do that exponent. 1.03 to the exponent 260. Because note, there's a multiply, 500 times the parentheses, and also an exponent. The parentheses times themselves 260 times. That's not something to even attempt without a calculator. So again, what does that mean? 1.03 times 1.03 times 1.03 times 1.03, et cetera, 260 times. So to do that with a calculator, what you do, you put the base on the screen of the calculator first. Press the exponent button, which on many calculators is this up arrow looking symbol, and then you enter the exponent, and then you hit equals. Now, some brands of calculator have a slightly different looking exponent button. Looks like that, x to the y power. It'll be one of those two. Then you put in the exponent, you hit equals. Same process, it's just what the button looks like. So, and again, you have to do the exponent before the multiply. Once you get that, then it's 500 times the answer. So I'm going to have A equals 500 times, when I do that, enormous exponent. So again, with your calculator, it'll be very easy. So I'll put in the base 1.03, press the exponent button. Oops, I forgot to clear it. Clear it first, put in the base 1.03, press the exponent button, put in 260 equals, and the calculator says 2176.097867. Now, I don't need that many decimals, and I will round it, but not yet. I want to leave all the decimals right now. They're on the screen of the calculator now. I just want to leave them there because the only thing that's left to be done is that answer that's on the screen now times the 500 that's in front of the parentheses. So I'm just going to leave the 2176 point whatever and just do times 500. It equals, and the calculator tells me that is 1088048.934. So first of all, now I can round it. I have 3 places after the decimal. In terms of money, that third position really doesn't have any meaning. So you're either going to round it off to 93 cents or make it 94 cents. The 4 in the third position isn't big enough. It's going to get chopped off at 93. It's going to be a 5, 6, 7, 8 in the third position to bump it up one, which you just don't have. So to do a nice job, let me put a dollar symbol. Let me start putting in commas. So as you start putting in the commas and writing it out a little bit neater, you realize that's more than $1 million. Starting with only 500. So that initial investment of $500 grew to $1,088,048.93. That's huge. With only 500. Now, a couple of things that make this really come out big. One is the 65 years. Most people don't have an opportunity to have a single investment for 65 years because the account was started when the person was a baby by its parents. That 65 years is possible. And it's really the last 10, 15 years where it goes from a big amount to a crazy amount. So if you do it for, say, 50 years, it'll be a lot of money, but not like this million. It's the last 10, 15 where it really blows up. And 12% is a little risky now. I did purposely make the numbers so that it would come out to a big answer. But the point is, compound interest is really something.